this is a quadratic, and we are asked to solve it by completing the square. By the way, I know it's a quadratic because I got an x squared term and I got an x squared term, or an x term. I'm specifically asked to complete the square, but in general, because it says solve, I know what I'm asking for is the x-intercepts, right? A quadratic makes a U-shaped graph. If we put that on a coordinate grid, the solutions are the x-intercepts. Okay. So graphing is one method that we could use to solve it. But we're not going to do that here. We're actually going to complete the square. So how do we do that? Well, the first thing we want to do is we want to get our x squared terms and our x terms kind of on one side. Normally we want the equation set equal to 0, but here actually we're going to move that 28 over. So I'm going to subtract 28 from both sides, and that is going to give me, let's see, x squared plus 12x. I'm actually going to keep my equal sign over here and just write the minus 28. I'm leaving myself some space because completing the square requires me to add a very specific number to both sides. Now there is just a rule for that number. That number we often call c, right? It would complete an ax squared plus bx plus c over here. And we get that by doing half of our b value. So we take this b value, we divide it by 2, and then we multiply it by itself. We square it. So in this case, this would be, right, 12 divided by 2. We would multiply that by itself. So it would end up giving us 6 squared, which is 36. So I can add 36 to both sides. And for a lot of students, that's totally fine, right? We have a set of rules, we follow those rules. But for most students, I would say it's helpful to really think about actually completing a square. And the way that we do that is we relate this back to a lot of what we did in class, which was building with some tiles, where an x squared piece was an actual large tile. And then we had 12 x pieces, little bars, and we would stack up, half going this way, half going this way, basically the same amount going in the vertical and the horizontal direction. So I could draw out 6 bars going this way and 6 bars going that way, but it's actually usually easier to just label it as 6x, right? Half of the 12x. Put half going up and put half going to the side. Now, this is not yet a square, right? It has an incomplete piece. We need this guy to be filled in. In order to make that a square, I need to add some certain number of 1 blocks there. Well, again, if we think of this as an area model, this is an x by x, and then this is x times 6, x times 6. So 6 times 6 is 36. If I put 36 ones there, I will have completed the square, and that is why this gets added to both sides. Now, the next step is to create a binomial to the second power, equaling, a number over here. And again, this is helpful if you see the area model. Look at the area model picture, right? It's an x by 6, or x plus 6 by x plus 6. So that's what goes in the binomial. It is x plus 6 times itself. X plus 6 times x plus 6 completes the square. This number over here I just get from negative 28 plus 36, which is going to be a positive 8. By the way, if you want the algorithm for what goes in the parentheses, just sort of what are the steps, it always ends up being x plus whatever your half of b is squared, right? Because it's x plus 6, and that's what we got from doing 12 divided by 2, that was 6. From here, it's all about solving with square roots. I'm just going to rewrite this line so I can kind of see what's going on. I need to get the x out of the square, so I'm going to take the square root of both sides. When I introduce the square root, it is really important that I account for both answers. So I do a plus or minus. And that actually makes sense if we think about it visually, right? We can have 2 x-intercepts, so I want to have 2 answers. Over here, these cancel out. That's what I want to have happen. So I'm left with x plus 6, and that equals the plus or minus square root of 8. Now, unfortunately, 8 is not a perfect square. If I was to type this into the calculator, we are unfortunately not going to get a whole number, right? The square root of 8, square root, there it is. It's this long decimal equivalent. So I'm just going to leave it as the square root of 8. It's totally fine to leave it in this state for the time being. I am, however, going to get x by itself, so I'm going to subtract 6 from both sides. And this looks a little bit weird the first few times you do it, right? Because this cancels, we get x equals. I'm just going to start this line with a minus 6, and then it's plus or minus the square root of 8. Now, technically speaking, this is correct. This is our answer. These values, which we could get decimal equivalents for, right? I could do negative 6 plus the square root of 8. And so my first answer is about negative 3.17. And I could do negative 6 minus the square root of 8. and it's about negative 8.8. So those are actually the x-intercepts. This parabola, this is not a very good picture, right? I just randomly drew this. Looks like my answers are over here on the negative side. Because when we do negative 6 plus or minus the square root of 8, I get these decimal equivalents, about negative 3.17, about negative 8.83. The directions on your assignment, though, said to leave it in exact form or simplest radical form. So you're pretty close here. The problem is the 8. The 8 has a perfect square factor. We need to rewrite that as this. 4 goes into that number, and 4 is a perfect square. So in a couple steps, we'll be there. We split this up. 4 times 2 is definitely 8, and then I split the square root over both. I did that on purpose because 4 is a perfect square. So I end up with this guy, which if you'll see when I go to the calculator again, negative 6 plus, negative 6 plus 2 times the square root of 2. By the way, just a reminder, you cannot enter the plus or minus together. You have to do them separately. That's why I did it as plus, and then I re-entered it as a minus. But you can see it's that same decimal equivalent and the same when I do the subtraction. This is just the simplified version. If you stopped here and gave me this as your answer, you would get an A on the problem. It's just not 100% until it is completely simplified. So this is the exact answer. That is your exact answer. If you did want approximate, we can pull it. We already did it. We did all the work. We plugged them into the calculator. If you wanted to write those out, that would be x is about, what do we say, negative 3.17, and I'm rounding correctly. And then also negative 8.83. It is a 3, right? Because that 8 right there tells me to round up. So these are the approximate answers. These are approximate. Good to know where it comes from, but I believe on your assignment you were asked for the exact and simplest radical form. So that's it. Hope that's helpful. Message me anytime with questions.